let's look at log graphs. We are given f of x is equal to 3 to the power x. That's an exponential graph. So let's sketch the graph of f of x. So to sketch the graph of f of x, you need the table method, and you're going to get your graph here. We've done this before in the exponential graph section. So you can just follow that example and draw your graph. The next one, determine f inverse x. So whenever you are asked to determine an inverse graph, you need to swap x and y first. So instead of y is equal to 3 to the power x, that will become x is equal to 3 to the power y. Here we go. Now we need to write in y form. So to get y out of the power, we need to use log. So y is equal to log base 3 and x. The base in the exponential graph was 3. It will remain as the base in the log graph here, 3. So y is equal to log x base 3 is your equation. So f inverse x is equal to log x base 3. Sketch the graph of f inverse x. You can use the table method again to sketch this graph, and you'll get a graph like this. Okay, remember to draw in your asymptotes. So f of x equals 3 to the power x for your exponential graph. That will have a horizontal asymptote here. And for your log graph, you can see that we now have a vertical asymptote here. So the next one is f inverse x a function, justify. So yes, I'm going to say that the inverse graph is a function because the vertical line test cuts the graph only once. The vertical line test means you can draw a vertical line that goes through the graph at any point on the x-axis. If the vertical line cuts the graph only once, then it is a function. The next one, if f inverse x is moved 2 units to the right and 5 units up to create h of x, write down the equation of h of x. So we said we're moving 2 units to the right and 5 units up. So if we're moving 2 units to the right, we need to minus 2 for x. There we go, x minus 2. And if we're moving 5 units up, we need to add 5 at the end of the equation. And this should be my new h of x graph here. The next one, we're given f of x is equal to log x base 4. We need to sketch this graph. You can use the table method again and you can sketch this graph. Done. Determine f inverse x. So remember, for inverse, you need to swap x and y first. So instead of y equals log x base 4, it will now become x is equal to log y base 4 here. We need to write in y form. So in y form, y will equal to my base is 4 in the log graph. It will remain my base 4 in the exponential graph. So y will equal to 4 to the power of x. Remember that the inverse of a log graph is an exponential graph. And the inverse of an exponential graph is a log graph. So f inverse x then will be 4 to the power of x. Sketch the inverse graph. You can use the table method again. And there we go. There's our inverse graph. Remember not to touch the asymptotes. Is f inverse x a function? Justify. Yes. Again, the vertical line test anywhere along the graph there cuts the graph only once. If f of x is reflected across the x-axis to form h of x, write down the equation of h of x. So if we are reflecting across the x-axis, I know that y becomes negative y. So h of x there will be negative of whatever the graph is. So it's negative into log x base 4. So h of x is equal to negative log x base 4 is my equation of h of x there.